divisional algorithm. If f of x and d of x are polynomials with d of x different from 0, and d of x is less or equal to the degree of the f of x, then there exist unique polynomials q of x and r of x such that f of x is equal with d of x times q of x plus r of x. F of x is dividend, d of x is divisor, q of x quotient, and r of x remainder. So what does it mean here? For instance, because f of x is dividend, so we can write f of x divided by d of x, because d of x is a divisor, so we can write it this way. But if we divide the function f of x by or polynomial function f of x by a polynomial d of x, we are going to get a quotient. Let me write a q of x. Let me denote a quotient with a q of x. But also, there is a possibility to be a remainder. There is a remainder r of x, which can be different from 0, or it can be 0. So, and this remainder is going to be d of x. But the remainder here, r of x, is with a degree less than the degree of polynomial function d of x. So the remainder can be a polynomial function which is with a less degree than the degree of the divisor d of x. And now if we multiply this equation, what we have now, if we divide it by a d of x, if we multiply everything by d of x, let me multiply by different number here. If we multiply everything by d of x, whole equation, this equation is going to look this way. For example, f of x is going to be times d of x. But let me write here with a different color, so that looks a little bit better. And d of x. And now I'm multiplying here by d of x, the left side, and same thing I'm going to multiply the right side with the d of x. And it's going to be equal with the q of x times dx times d of x. So with this here. And same thing I'm going to multiply by d of x the last term, which is plus r of x since I have a blue, let me write here a d of x. And let me change the color, maybe it looks a little bit better. I am multiplying the third term by the function, by the divisor or the function d of x. And now here we can simplify this function. We are looking what we can simplify d of x or d of x in the first and the third term. And now let me write here f of x is equal, we can rearrange a little bit d of x. Let me put here in the front because commutative property in multiplication works, is valid. So I can write d of x times q of x, and in the end remained just the remainder plus r of x. So the statement what we have, the division algorithm, what we have here in this statement here. So now if the remainder f of x is equal with 0, then d of x or q of x, both of them are factors of the polynomial function f of x. But if r of x is different from 0, then d of x or the q of x are not factors of the polynomial function f of x.